Hey guys, Ben here, 3dgladiator.com, and in today's video I'm gonna show you how to restore a broken 3D scan. Depending on the tools you use, 3D scanning or the photogrammetry method already delivers very accurate results. But still, it is sometimes necessary to complete the model or adjust parts of the mesh by hand. And in today's demonstration, I'm gonna show you how to finalize pretty much any 3D scan in ZBrush together with a free tool called GOM-Inspect. I'm gonna do this on the basis of a model that I've just fixed for one of my clients. In addition, and this is really cool, the final model will be available for free download soon. Actually, not only this model, but many more beautiful sculptures. This is so special that I'm gonna talk about it more in a separate video that I will upload next week. So for this one, I will briefly show you how the model was created, and then we take a look on how to separate parts of the mesh, how to close all of the holes, and how to reduce the surface noise. Last but not least, I will try to recreate some hair at the back of the model's head. The tutorial is addressed to slightly more advanced users that already have a good understanding of several techniques and workflows in ZBrush. So let's get started. This is the model I've received from the client, and this is actually not a 3D scan. It is created by a method called Photogrammetry, and you probably already know how this works. So you basically take a lot of pictures from different angles of one object, and then you import all of these images into a special software where the pictures get aligned, and by aligning these pictures the program is able to calculate a point cloud, and then you can turn the point cloud into a 3D mesh and export the model also with textures as a 3D model in a common file format. And that's the exact way how this one is created here. I can show you the source images. And as you can see here, the pictures were taken from all angles, and of course the more pictures you have, or the more pictures you feed the application with, the better the result will be, and the better the pictures, the better the final 3D model. The method has also some downsides, as you can see here. So the bottom of the plate is missing, then we have a lot of holes at the plate, and also some distorted areas at the back of the model, especially where parts were in shadow. Then we have holes at the top of the head or at the forehead where the hair is, and we have a lot of surface noise and irregularities pretty much everywhere. And in this video I'm gonna show you how to get from the original photogrammetry result to a model that's a little bit cleaner and has no holes. That's the version I'm currently working on, and as you can see, I've reconstructed parts of the plate. The bottom is not missing anymore, then the holes are closed around the forehead, and I have also closed the hole at the back of the head. This was requested by the client, so he's looking for a version with the hole and one without the hole. So I've simply taken some of the hair strands that were already existing on the model and duplicated them to create the cap or the back of the head here. And I would like to quickly show you what you need to look out for when you work with 3D scans or models created with the photogrammetry method. The main goal of this project is to restore or to get rid of all of these problematic areas without losing any of the details from the original photogrammetry scan. And this is also the challenging part here, because losing these fine surface details happens quite fast when you turn the mesh into a dynamesh, for instance. Actually, the method you use really doesn't matter. You can use dynamesh, you can retopologize the whole thing and continue with geometry that has subdivision levels, or you can only use the sculptor's brush. that really doesn't matter as long as you are able to maintain the surface details or the details from the original scan. I usually look for areas that I can separate. So in this case, I'm gonna separate the head from the plate. So I have them on separate subtool layers and work on them individually. The head is already pretty perfect, but the plate needs a lot of work. I start by deleting the version that I've already created, so that we can continue only with the original scan that was imported as an OBJ. And the very first thing I'm gonna do here is I will mask the head like so, and then I will make sure that only the head is masked and none of the plates. So I simply unmask parts of the plate, and then I switch over to the tool palette and go down to the masking sub palette and click on grow mask a couple of times. So also the bottom area of the hair gets masked. So simply click on grow mask a few times. And this tends to blur the mask quite a bit. So after you have clicked on grow mask a couple of times, it's a good idea to press sharpen mask once and then grow the mask again just a little bit, sharpen it one more time. And then last but not least, I'm gonna mask any missing areas by hand, like this area here, or this part here. Oh, it looks pretty okay. Then I simply hover over the mask parts and press Ctrl W on the keyboard, so the mask disappears and gets replaced by a polygroup. And then we can simply click on the polygroup to isolate the head. And as you can see, two little pieces of the plate are still here. So I hide them too, and then I can simply separate everything that's currently hidden. So I click on split hidden, and this places the head and the plate on a separate subtool layer. The next step is easy, as I'm gonna turn the head into a dynamesh, but before I do this, I create a copy. You can do this by going to the tool palette and click on duplicate. And when I zoom in close and show the wireframe by hitting Shift F on the keyboard, you can see that the mesh consists of triangles, because triangles are the only way to turn a point cloud into a mesh. And you also notice that the actual surface is not that dense. It only consists of around 900,000 active points. And the triangles help to transfer a lot of these small surface details. And when we now turn the model into a dynamesh, I aim for a point count that is quite higher than the 900,000. I'm looking for a point count between 1.5 million and 2 million, and that should be enough to maintain the details. So when I bring up my custom menu here and set the dynamesh blur value down to 0, for the resolution slider, there's a little bit of guesswork involved now. Maybe 1500 is already too high, so let me try 1K, and I click on dynamesh and give ZBrush a few seconds to make its calculations. And there we have it, our dynamesh. And if I zoom in close and switch between the previous version and the dynamesh by hitting the arrow keys on the keyboard, you can see that all of the surface details are still there. And I have now an active point count of 1.8 million for the dynamesh, which is double the amount of the active points from the previous version, and that should be enough to continue working without losing any of the details. So dynamesh does not only close any holes, it also assigns polygroups. So I can simply Control Shift click on the cap and get rid of everything else except the bottom part. Then I mask it by hitting Control A. I show the entire model again. I invert the mask. I hit the W key on the keyboard to bring up the transformation gizmo. And then I move the base down quite a bit, like so. Unmask the model, switch to the clip curve brush, and then I cut the base straight like so, so that we end up with a perfectly flat base. And I do this because I would like the head mesh intersecting the plate that I'm gonna fix next. So all that's left is to run dynamesh one more time. So simply draw this little mask rectangle next to the model, give ZBrush a few seconds again, and then we are good to go. Actually, it has done a perfect job closing the hole at the bottom, because if you are dealing with these complex shapes, at least in previous versions of ZBrush, dynamesh was bridging the gap here with a flat piece of geometry, and this is of course not what we want. But for now, the base looks pretty perfect. So in the next step, I'm gonna close these holes here, because we probably still have some chunks of geometry inside the head. So if I hide the front part, oh, let's hide the back part of the model. You can see that there are these pieces of geometry located inside the head, and this is mainly because dynamesh was not able to close the holes at the front, and so it tries to rebuild the surface also on the inside. And that's what we're gonna fix in the next step by closing these little holes. This can be easily done with the inflate brush. I set the C intensity for the inflate brush to 20, and then I start closing the holes like so. So this hasn't to be perfect, because the sole purpose of this method is to make the mesh intersect in these areas, and then I run dynamesh again to merge the pieces together, or the overlapping areas together, and that should get rid of the internal chunks of geometry. And then I simply clean the surface again. And sometimes you also have to mask one half of the hole, so you can move the other half over and make sure that these areas are intersecting or touching each other at least, so that dynamesh will combine them into one piece of mesh. I'm sure you already get the idea, so I will pause the video here, continue to close the holes, and then show you the mesh again before I run dynamesh. I am now done with closing all of the holes, and I would like to show you another little trick here that makes this process a little bit easier. So if you hide parts of the mesh and then go to the tool palette and down to the display properties sub palette and enable double, you can see the pieces of mesh on the inside a little bit better. So This allows you to locate the holes on the outside and close them, and then we should be good to go to run dynamesh one more time. So I give ZBrush a second or two to make its calculations, and then I again isolate parts of the mesh, and as you can see now, the chunks of geometry we previously had on the inside are now gone, and the model looks pretty perfect. This part, of course, comes from the opening or the indent at the top, and this is perfectly fine too. Last but not least, let me make the base flat again by switching to the clip brush and cutting off some of these little bumps, and run dynamesh one more time. So we could now continue the same way with the base, but as the base is so incomplete, ZBrush will have a hard time on closing the holes. Basically, there are two ways to close holes in ZBrush. You can turn a mesh into a dynamesh, and dynamesh will close all of the holes for you, or you can go to the tool palette, open up the geometry sub palette, and go down to the button that is called close holes. So if you click on it, ZBrush closes all of the holes of a mesh without affecting any other parts of the geometry. I've already tried both methods, and unfortunately both ended up in a calculation that took more than half an hour with a result that was far away from satisfying. So this makes it necessary to export the mesh as an OBJ or an STL file and use a second tool to close the holes. And I use GOM-Inspect for the next step. It is a tool that's available for free on GOM.com. So it's a piece of software that allows you to import all sorts of 3D files and CAD data. You can turn a point cloud into a mesh and run several inspections and evaluations. And I only use the mesh tools in GOM-Inspect. I've already loaded the exported STL file of our base, and the very first thing I'm going to do here is I go to Operations, Mesh, Close Holes, and select interactively. This brings up this little toolbox, and I set the filling result to plane based first, and then I simply zoom in a little bit and control click on an open edge of the hole at the top. So then I get prompted with a little warning message where GOM tells me that the selected hole is very large. Would you like to proceed? Yes. And then I give it a second to rebuild the surface here, and that looks already quite okay. So I proceed with the bottom part, and here I first set the filling result from plane based to normal, as GOM is not able to create a flat cap here. And then I simply zoom in again and control click on an edge, click on OK when this little warning message pops up. And this probably takes a few minutes, but GOM should be able to close the hole in a way that we can export the mesh as an STL file later on and continue cleaning it up in ZBrush. So I'm gonna pause the video here and see you in a second. After 2 minutes, GOM comes up with this result. So of course it is still far away from perfect, but at least the opening at the bottom is closed in a way that we can use the curve tools in ZBrush to make the base flat. I could now continue closing the rest of these holes, but this job should be also manageable in ZBrush. So I'm going to export the base as an STL file again, bring it to ZBrush and continue there. So I go to File, Export, Mesh, and save it as an STL file. Back in ZBrush, I exit the edit mode by hitting the T key. I clear the canvas, select the simple brush, so none of these tools is selected before I open up the C plugin palette, and here I go to the 3D Print Hub and click on Import STL file and import the file that we have just exported from GOM. And then I switch back to our tool again, open up the subtool palette like so, and append the new plate. And let's also hide the old one. And before I turn this guy into a dynamesh, I go down to the geometry subpalette and click on close holes. And now I can bring up my quick menu again, set the blur value for the dynamesh down to 0, and let's choose a resolution of 800 and run dynamesh. If we now compare both meshes, so the new one and the one that we have exported from ZBrush, you can see that the details, or in this case a lot of the surface noise, is still there. The old one has a point count of around 500,000 and the new one is a little bit above the million, mainly because of the caps at the top and the bottom. And I select the clip curve brush next and make the base flat again, like so. Now, instead of fixing these still heavy damaged areas here by hand, I'm gonna copy an area of the plate along the edge and merge it into the main part of the mesh with dynamesh. So first I look for a section that is still quite intact. So it's probably this one here, because the top looks okay, the edge looks okay, and the bottom looks okay too, except of this hole here that I'm closing in the next step. So I select the inflate brush and close the hole at the top first, and then continue at the bottom, like so. It doesn't have to be perfect again, it's all about having the mesh intersect in this area before I run dynamesh again. And then I use the edge polish brush together with the standard brush to clean up some of these bumps and to reconstruct the missing edge, like so. Then I'm gonna duplicate the model by hitting Ctrl-Shift-D on the keyboard, and I make sure that the select rectangle tool is selected. Then I hide most parts of the mesh, switch to the select lasso tool, hide also these parts. Let's see what this looks like. Okay. Then I'm delete everything that's currently hidden. I switch to the inflate brush again, close these holes a little bit, like so. So I should have done this before I've deleted the rest of the mesh and run dynamesh one more time. But as we have to fix the plate anyways later on, or run dynamesh anyways later on, it is totally okay to do it rough and sketchy now. And then let's show the rest of the plate and hide only the head part. And now I hit W key on the keyboard to rotate this little piece in place, like so. And we probably also have to adjust the position and the rotation. Then I'm gonna duplicate it again center the gizmo to the main plate, and then slowly rotate this part over like so, and position it again. Let's see how this looks at the top. Still okay. Then I'm gonna copy it one more time, rotate this part again like so. So the goal here is to reconstruct the edge of the plate without without manually building it up with different brushes. So these edges here are totally okay. You can always select the move brush and move them in place like so. And I'm gonna repeat these steps for half of the plate. So I'm gonna cover these sections at the top and the bottom, and I will probably leave these areas untouched because we have also some unique details here that I would like to keep. So I'm gonna pause the video here and I show you the plate with all of these parts before we merge everything into one piece of geometry with dynamesh. Okay, so this is what the plate looks like with the rebuilded borders. As you can see in my subtool palette, I have quite a few of these parts placed along the edge here. And before I can merge everything together, I have to combine these subtools. So I start with the main part of the plate first, and I simply click on merge down to combine it with the subtool that's below it. So I do this a couple of times until we reach the very end of the list. Now we have all parts and the main part on the same layer, and all that's left to do now is to run dynamesh again. So let me quickly check if dynamesh is still active. Yes, it is, and the settings are still the same. So I draw this little mask rectangle next to the model and give ZBrush a few seconds to build the mesh. Okay, and this looks pretty good. All that's left to do now is to fix some of the remaining areas here, and you can simply do this with the smooth tool, the move tool, and the edge polish brush. And we can also try to clip the bottom one more time like so, and this should get rid of these little lines. And from here it is quite simple to clean up the remaining arrows. And ZBrush did an excellent job combining the single pieces. So let me quickly also show the head mesh again. And I will probably also get rid of some of the surface noise. I'm not going to make it perfectly smooth or perfectly flat, because that would take away some of the realism, because we have some surface noise also in the head area here. And I'm gonna show you a little trick on how to do this without having to go over all parts with the smooth brush next. Let's start with the head mesh first. So I'm gonna focus on the beard and only on a few areas of it. And for this reason, I mask parts of the mesh here. And it's always a good idea to focus on smaller areas when removing surface noise instead of the entire mesh, so that lets you control the amount of smoothness. And when I'm done masking these parts here, I'm going to invert the mask. And I will also hide the mask by hitting Ctrl H on the keyboard. The area of the beard is still unmasked, so this is just to make the difference between the masked and the unmasked area a little bit more clear when I now open up the deformation subpalette and set a value for the polish function. So let's try a value of 12. Then I hit OK, and ZBrush gets rid of the surface noise. So you can see a clear difference between the original and the polished part. And you can now continue smoothing out certain things with the smooth brush, or highlighting some of the edges with the standard brush. This is exactly what I've done now with all other parts of the mesh. As you can see, the surface noise on the hair strength is gone. I have also worked on the plate a little bit and sharpened the edges of the leathers. And I've also smoothed out some of the surface noise we had in the face and got rid of the cracks there. And in the next part, I'm gonna focus on the indentation at the back of the head, and I'm gonna fill the hole with the clay buildup, the standard and the damp standard brush, and try to create a nice parting line of the hair here. So I'm not gonna copy existing hair strengths to cover the indentation. I'm gonna recreate this part by hand. So the first thing I do is I create a copy of the existing model by hitting Ctrl-Shift-D, and then I switch to the clay buildup brush and set the intensity value to something like 15. You must know that the mesh is still a dynamesh, of course, and I've also combined the head with the base or with the plate. So if I zoom in close and show the wireframe, you can see that we are dealing here with one part, and the head still has a poly group assigned to it. So to fill in the hole, I simply isolate the back of the head like so, and then I start filling in the indentation with a clay buildup brush. So this process can be sketchy. Again, the important thing is that the parts of the mesh are overlapping or intersecting each other, so that when we run dynamesh in the next step, ZBrush combines these parts of the mesh into a clean and smooth surface. So I'm using the existing geometry to build up some volume here. And then I show the entire mesh again and run dynamesh. And then I continue building up the single hair strengths. So at this stage, it already makes sense to define the parting line a little bit. So I switch to the damp standard brush and try to draw in the parting line of the hair from front to back, like so. And then in the next step, I build up the single hair strings in a way that they end perfectly in the parting line. So again, this process doesn't have to be perfect. The main goal is to establish the primary shapes, and then I will focus on the details, or on adding details, or continue the details of the existing hair strings in the next step. But first we must make sure that the volumes are correct. And for this reason, it's also a good idea to look at the model from the side and use the move brush to adjust the outlines. And in this case, we need a little bit more volume for the entire section here, so I'm going to move out the parting of the hair a little bit to add some volume to the entire area. Like so. And in this case, of course, it also makes sense to show the entire model to get these outlines right. And while we are having the complete mesh visible, I simply run dynamesh one more time and continue to define the single hair strands. And I first try to get rid of some of the surface texture that was introduced with the clay buildup brush, and I use the clay buildup brush again to build up volumes, so it's a bit of a back and forth process. And then I also use the standard brush and the dam standard brush to elaborate and define the flow of the strands. Like so. And this process simply takes some time. So I'm also not gonna finish a single hair strength. I switch between different ones and try to work on them simultaneously to get a better understanding of the shapes. Let's see if we can make this a little bit more natural. And let it end somewhere like here. Don't forget that you can use the dam standard brush also the other way around, so you can not only draw in lines, but you can also define edges by pressing Alt. And then I try to continue these lines here with the standard brush. And the dam standard brush again. The goal here is to copy the look of the already existing hair, so that you cannot distinguish between the new one and the original one at the end. And make it as natural looking as possible. And I then simply run dynamesh again whenever I feel that I need a little bit more points or polygons to work with in certain areas. So if I push in or pull out the surface quite a bit, I end up with areas that are quite distorted, and in this case you can simply show the entire mesh again, run dynamesh, and then continue sculpting. I'm also gonna flatten out some of these smooth areas here, as these sections are not smooth on the existing hair either. And I simply do this with the Edge Polish brush and the lazy mouse function enabled for this brush. And try to slowly mimic the existing strands. And it's very important here to maintain the flow, and for this reason I show the entire head from time to time to get an idea how to continue these lines. And then I isolate parts of the area I'm currently working on to speed up the workflow a little bit. In this case, it's not necessary to have the entire mesh visible all the time. And depending on the details or the things you are trying to recreate, this process can be quite complex and complicated and take time. And sometimes you also have to let it rest for a few minutes so that you can come back with a fresh eye, well, with a fresh view, to find out which areas still needs to be improved. So I'm gonna pause the video here, as I'm sure that you already have a very good idea how this works, and I'm gonna show you the final result next. So this is what the sculpture looks like after another 30 minutes of work. As you can see, I've completed the single hair strands and the parting of the hair, and all that's left to do now is to make a quick render for presentation. And I simply do this by enabling perspective first, by hitting the P key on the keyboard. And whenever you have the feeling that the model gets distorted too much on the canvas, you can change the focal length. And in ZBrush, you do this in the draw palette. So if perspective is enabled, you can change the angle of view. So if you set the slider to a higher value than the default one, the model gets distorted even more. And I usually set it to something low, like 35. And then I also adjust the position of the light. I move it over to the right slightly to bring out the shapes even more. And then I simply hit Shift R on the keyboard to create a render, and ZBrush adds some shadows and smooth out the edges. And then I usually make a screenshot, and then I'm good to go. Alright guys, so that's it for this demonstration. If you have any questions, please leave a comment below this video, and see you in the next one. Cheers!